Okay, welcome back, Algebrists. Today, we are getting a very beginning start in 2.3, where we are going to be looking at factoring quadratics. Factoring quadratics. Now, whether you remember it vividly and exactly how to do it or not, I'm certain that if you took an Algebra 1 course, you've done all this stuff. Maybe not super well, but you've done it all. And it's just a matter of getting it to come back. So right off the bat, we're just going to jump in with a really quick definition. What is factoring? Like, what is it even asking for? Breaking it down into what? Simplest. There's a better word for that. It starts with p and ends with rhyme.
Prime.
Factoring it down into its prime pieces. Now, whether you're aware of it or not, do you, and I guess you will be aware of it, anybody think that this really matters for your everyday life?
No.
Probably not. Like, realistically, like, honestly, you probably have no idea. I'm about to blow your minds. We don't get to deal with it. Factoring can be hard. You guys started factoring probably like 4th grade, realistically. It's not like this. It's number trees. Do you remember factoring down number trees?
Yep.
Something like that.
Okay. So, quick question. There's an obvious answer, and it feels like a silly question. Anybody ever typed in their credit card information or anything super personal on an online form?
Yes. Yeah.
Okay. If somebody were, you've never bought anything online.
No, actually, not online.
You don't think your social security number's ever been typed in? Like, you've never ordered anything off of Amazon?
Not me myself. I use
Your
those others.
social security.
No, you're not ordering
No, but like,
off of Amazon, but credit card.
I go, Mom, I want to buy this.
Okay, so let me
I don't
rephrase. Have you or your parents ever used their credit cards on the interweb?
yes.
Okay, yes, obviously, right? Now, if I'm a hacker, and we're not going to go into the computer science side of all of it, but hypothetically, let's say that I have a way to watch your communication, and there's nothing special about it. I could now theoretically then have your credit card information.
Watch our communication.
Yeah, so like if I intercept your signal, right? So like let's say I put up a thing and you connect to a fake Wi-Fi that I've set up. That's really the same as yours, but it stores everything you type in or whatever, or it tracks what the traffic might do. Hackers have ways to do this. That's not our focus. I don't have a fake Wi-Fi in here anywhere. Never plug in a USB that's not yours and you don't know the person that gave it to you. Like if you pick one up somewhere, don't plug it in your computer. Never. Never, never, never. I found a sweet charger at the airport this summer that was like a power bank that I really wanted to use, but I don't know where it came from. If I was somebody who wanted to steal my identity or anybody's identity, and I knew if I was computer savvy, I would just do it on a flash drive so when they plug it in, it sends me everything that they do. Don't plug in random stuff in your computer. When the FBI, CIA, any of those places get hacked, the easiest way for any counter-American person to do that is to go to the parking lot of that place and drop a flash drive. Because somebody's going to pick it up, they're going to carry it into their office, they're going to say, oh, I wonder what this is, and they're going to plug it in, and now the whole network is at risk. Okay, if you or anybody you know has ever ordered anything off of Amazon, the good news is I don't think that your information has been stolen. Okay, on every website that you ever buy stuff, if you don't do this, you should. It looks a little different on a phone, but you can always view the store information. Okay, the cookies, whatever, it tracks so it advertises stuff that I've searched. That's all that cookies are. If we go a little bit further into it and we look at the site settings, just kidding. I got to go to not site settings, but the connection settings. If I look at the connection and I go, yeah, I would like to see the certificate that they have. This is what you are after. If you go to a website and you see SHA 128, I wouldn't trust the website. Like SHA 128 and SHA 256, these are types of what we call encryption. It's really hard to find prime factorizations of stuff, and computer security uses that. If I want to send something securely, we're not going through the whole process, but it starts with my computer picking a 256-digit long prime number, a huge number. Now, factoring a big number like 1,015, it takes a big number tree, right? What if that number, instead of 1,015, which has 4 digits, what if it had 200 digits or 256 digits? It's a hard thing to do. Even computers struggle to do it with that much. But if I have a really big prime number, and you have a really big prime number, and we do some fancy math with it, we can ensure that we're only talking to the person that we're supposed to. There's a lot going on there. That is SHA 256 in a heartbeat. What we do today with just our factoring stuff, it does have applications in your everyday life. If you've ever sent a message on Snapchat and hope that not everybody else sees it, it's because it's encrypted via something very similar to this, which it all relies on factoring. Now, Do you really need to know how to factor to trust the internet? No. But if there's any part of you that just now you're like, oh man, that sounds pretty cool actually.
So is that your number then?
Nope, SHA 256. This is a certificate, and here's the public key. Everybody can see this, and this is a really big prime number written in a different format than we're used to. It's called hexadecimal. Yep, this is a really big number. I have my own really big private number, and Amazon has their own, and when we multiply them, we get a new really big private number that we both know because we had both of them. Okay, that's the basics of it. There are tons of videos online. That is factoring. Now, factoring, when you first saw it, you don't need to write it, but do you guys remember doing this? 122. How do I factor this? What goes into it for sure?
122 and 1.
So something more meaningful, but you're right. Does a 2 go into this number?
Oh, yeah.
Yeah, and I think it's what, 61 times? And then 61 feels prime, but I don't know if it really is. It's not. This is 3
Oh. 3 and
times 19. Is that true? No, 3 doesn't go into it. Is that prime?
I think so.
That was a terrible choice then.
Because it's, yeah.
We're going to do 124 to make sure it works. Okay, you guys have probably done this. 2 times 62 is 124. And 62 is 2 times 31. And I'm just breaking it down. I'm just using 2 because it's obvious. That means that 124 can be written like this. That's still 124. That's what we call the prime factorization. Does that look familiar? Okay. So when we factor, all that we're really doing is breaking something, and it can be an expression, it can be a number, breaking an expression for our purposes into prime, which just means we can't simplify it anymore, pieces whose product is the expression. Whose product is the expression. All right. Everybody cool with just that first basic idea. We just have to break it down into its parts. Now, for our next little piece, travelers, especially if you're leaving at 05, you're going to miss a couple parts. Here is my guideline. Now, I essentially have a flow chart. I'll give you guys a big scary looking piece of paper later. We don't need it yet. When we're factoring, here is kind of my idea and how I teach it, how you'll see me refer to it every time moving forward. I refer to what we're about to see as our roadmap. If you'd rather call it a flow chart, I'm good with it. Okay, here is the very precise set of steps that we follow and I follow and hopefully you'll follow as we factor. Okay, step 1. Before we write it, every time we're going to check this. I'm going to write the letters, and if you can tell me what it means, I'm cool with it. GCF. Greatest common factor. Is there something that goes into all the pieces? Now, we will do examples of each of these over the next few days. Just so you know, 2.3, this lesson is going to culminate with a factoring quiz. It's going to happen. Just nothing but factoring. Okay, once it's there, greatest common factor. And we're not going to do any examples right now, but once we've done this or we've seen there aren't any, we'll pause. Cool. All right, always, GCF. Now, what is the Greek word for two things? You don't write a 2 cycle.
Mono? Wait, that's 1.
Uni is 1, or mono if you're in Latin. What about, like, if I get on my 2 cycle and pedal home, that sounds dumb. You're going to call it a what cycle? Or sickle. I don't think I'm going to ride my unicycle home, although I appreciate your...
Bicycle.
My bicycle. Bi means 2. Check it out. If we do or don't have a GCF, our next step is a simple question. Is it a binomial? Which binomial simply means how many terms? 2. Okay. If it's a binomial, there's an extension. We are going to use what is known as our difference of squares. What does the word difference mean? Subtract. So if we see a subtraction with a binomial where we know that both of them are nice squares, which we'll deal with what that means, that is our next step. Always, GCF, difference of squares. From here, if it's either we've done it or it wasn't a binomial, instead of 2 pieces, it could have 3, right? What am I going to call that?
Triangle.
Is it a trinomial? 100%. 3 terms. Okay. If there are 3 terms, which there were a couple on the bell ringer that had 3 terms, I'm cool with that. The order here can be kind of different. It depends, but there's only a handful of things we're going to check for. The very first of these is a perfect square trinomial. And you are likely not aware of it, but we've actually used perfect square trinomials multiple times this year already. We've seen them, we've worked with them, we've just never used that language. We're going to check, is it a perfect square? In the next couple days, we're going to refine what all these things are. So if you're looking at it going, I don't know what the hell this is, that's okay. Don't need to yet. You're going to learn. Okay. If it's not a perfect square trinomial, or if I'm not sure, I might check to see, is the leading coefficient, which I'm going to write LC moving forward, is the leading coefficient equal to 1? If so, I'm just going to put in parentheses, we have a shortcut. And it's super handy that we have the shortcut, but instead of just saying, here's the shortcut, we're going to develop these things over a couple days. Okay, let's say that we went through, it wasn't perfect, the leading coefficient was not a 1. Let's pause here. So, continuing on. GCF, always. Then we check if it's a binomial, and if so, we'll do whatever this means. If it's a trinomial, we check, is it a perfect square trinomial? Did you guys hear something? Somebody forgot a bag or something, and they're just going crazy. All right, last little thing, 2 pieces. If the leading coefficient, LC, is how I'm going to shorthand that, is not equal to 1, grouping. Okay. It's weird, you will not hear this on the microphone. I guarantee it. I need a better mic to pick up your guys' voices too, so that when we get answers, but that's okay. All right, very, very end. This one is, I'm just going to put an asterisk here because it's kind of its own standalone thing because it's a very specific situation. Everybody's favorite, if and only if we need it, we will use the quadratic formula. Now, just a quick check to get a feel from you 5 that are here right now. Do you recognize GCF?
Yes.
Yell, do you recognize it? And you took math last year in the Philippines, right? So a couple random questions. Do you learn math in English? Okay, so does this sound or look familiar? Okay. Jade and Kian too. Do you recognize binomials? How about a difference of squares? Does that sound familiar?
Maybe.
I know it's
Maybe. Okay. Trinomial, definitely. Perfect square trinomial.
Yeah.
Leading coefficients,
Maybe.
quadratic formula.
Yes.
All right, we're gonna go see if we didn't miss anything because they all just walked by. I don't know.
I'm getting
Yeah, let's not let's not mow. You can go check it out. I'm cool with that. Thank you guys for indulging me. I thought we were done out there.